Intelligent terminals have a long tradition at Beckhoff. Today we're going to talk about the servo terminal. Dieter, what are the advantages that these new servo terminals offers to customers?
With this new product line, the ELM terminals, we have, as already known, a one-channel version and new, for the first time, also a two-channel version.
And Dieter, how can this new servo motion technology, this new servo terminals, how can they be integrated into the existing I/O system?
Let me explain this on this short video. So here you can see that the new ELM terminals can be integrated directly in the standard I/O system from Beckhoff. This means these terminals are an integral part of the Beckhoff I/O system. And as you see it here, the DC link will be fed in the same way as we know it from our EL terminals. So the DC link can be provided by 8 up to 48 volts. For example, the one-channel version. Here we have a metal housing. So for that we have an optimum heat dissipation even at high output powers and a perfect shielding against electrical interferences as well. For the connection of this module, we have a comfortable plugged front end and a proven OCT technology to connect the motor, brake and the feedback in one cable. For the I/O and the motor connector, we are using push-in spring clamps. This provides a fast and quick installation in the field. For the DC link connector, we are using a PCB connector, also with push-in technology.
And Dieter, can you tell us a bit more about the compatibility to the existing servo motion system?
Yeah, of course. The functionality compatibility is provided. That means with even more additional features and functions, we are able to extend the possibilities of use. More about this later on. As usual, we have the integrated absolute encoder interface, OCT for motor connection, brake and feedback, and additional inputs to latch position or detect the end positions of the drive. And we have a variable DC link voltage from 8 up to 48 volts. We have a shield clamp integrated, so therefore we have a direct connection from the shield of the cable to the metal housing of the terminal.
Dieter, you mentioned that the servo terminal comes in a metal housing that offers a very good heat dissipation. Now, what does that mean for the power ranges that we offer?
We have 3 different kind of performance classes. We start with the 4.5 amp terminals as a 1 and 2 channel variant, go up to the 8 amp terminals also as 1 and 2 channel versions available, and last but not least our new performance class, the ELM 7231 as a 16 amp servo amplifier.
So Dieter, now we are in the field of servo motion, of moving parts. That means we need to have, or to be able to make our machine safe. What safety functionalities does the servo terminals come with?
Safety is an integral part of our motion technology. So therefore we have 2 different variants of these terminals. The base variant is the 9016 with STO and SS1 via FSOE, and the extended version 1918 with a complete safe motion package. With that we can realize more extensive safety functionalities like SLS for safe limited speed or SLP to detect a safe position. All these variants of the terminals comes with a twin-cat communication via FSOE. That means that the safe protocol will be transferred directly via EtherCAT. We have an integrated twin-safe logic. That means that the safety application is running directly on the terminal. With this new performance class, we achieve an output current of around about 16 amp and a peak current for 1 second up to 32 amps. With this new terminal, we're doubling the output power in relation to our standard EL terminals.
Why did we opt for a 1 kilowatt power range? And finally, what kind of application does this new servo terminal address?
Most of the motors in the field are rated to 750 watt. With our, let's say, old product family with the standard EL servo terminals, we were able to run motors up to 500 watts. With these new performance class, we are now able to control these typical motors with a comfortable control reserve. Further applications are HGV applications, that means battery-powered self-driving vehicles. Further reasons can be seen here. We have a fast current of 16 amp to the motor. That means a total power consumption at the DC link output of the power supply unit for around about 20 amps. When we now take a look at the world of power suppliers for industrial use, exemplary our portfolio, we see the one-phase and three-phase units. Both provides a maximum output current of 20 amp and a peak current of 35 amp for 1 second. Also, power supply units from competitors for industrial use has the same limitation.
So now we've seen what kind of power ranges we can actually reach and achieve with this new servo terminal. But Dieter, what kind of speeds and torque can we expect from this servo terminal?
With our EL terminals, we had the limitation to 8 amps. Now for this new class, we have also new motors, which has a power range from 12 up to 16 amps. And depending on the winding type, we can achieve an output torque of 3.9 Newton meter or a rated speed up to 8,000 RPM. Of course, there are also the matching connection cables available. We start with 2 variants, one for the fixed installation and the other one is suitable for drag chains. Marvin, can you show us how easy and fast is the setup in TwinCat 3?
For sure, Dieter. But first of all, before I start talking about the commissioning, I would like to focus on the designing of a machine. In TwinCat 3, there's already an existing tool for that, the Motion Designer. And now also the new ELM terminals are integrated into this Motion Designer. You can use that to already pre-configure your dynamic parameters in your whole machine and then end up with the specific product code of your needed combination of amplifier and motor. Now let's take a closer look at the commissioning in TwinCat 3. Here you can see in the background a configuration with the already scanned ELM terminal, which you can see down below in the I/O area. While scanning your hardware, TwinCat automatically asks you if you already want to link an NC axis. This can be done within one click in a dialog window, and you can already see here in the motion area. If you now want to configure your application-specific dynamic parameters, you can do this in the Drive Manager 2. This is also an integrated part of TwinCat 3, as the Motion Designer, for example. And now we can take a look how it, for example, looks like when you tune your axis in the Drive Manager 2. Here you can see a complete overview of all the control loops available for your ELM terminal, starting with the inner current controller, the velocity controller, and the outer position controller. If we now take a look, for example, into the current controller, you can see that you can set here the KP and the TN of the current controller, but for example also filter settings. But for most of the applications, it is not needed to tune the current controller because of the already mentioned OCT technology, which Dieter just mentioned. It is already pre-configured because the terminal reads out all the motor-specific parameters out of the motor and sets it already in your application. If we now take a look on the velocity controller, which can also be tuned here by the KP and TN factor, for example, you can start tuning your axis depending on your specific movements in your machine and the load conditions. The same applies to the position controller. And if you now insert a TwinCat 3 scope view project, you can start a split screen view with the scope on one side and the current control loops on the other side and start tuning your machine. And you can then see in real time which effect this tuning has on your machine. Now that we already talked about the scope, here is another scope where you can see a new feature of the ELM terminal, the Cogging compensation. Maybe you know it when you start turning a servo motor that there are these little frictions during the whole movement of the shaft. And this is created by the motor magnets. And this leads to not so smooth movements in the machine at low speed. With this new feature, we can compensate this friction. For example, here we can see a movement of about 80 degrees per second. And with the deactivated cogging compensation, you see a velocity ripple up to about 20%. And with simply activating this cogging compensation, we lower this velocity ripple to only about 2%. So this comes in very handy in interpolated applications, for example, for the machine tools industry.
That's well integrated in Twinket. And now I would like to give out a summary about the highlights and features of this new product family of servo amplifiers from Beckhoff. So we have the 1 and 2 channel versions up to 500 watts, and new, this 1 kilowatt version in a 1 channel terminal. All of these terminals has a shopper functionality integrated. That means a braking resistor can be connected directly at the terminal. We have a comfortable connector front end. With that, we can realize an easy and quick installation in the field. All of these terminals has TwinSafe integrated via FSOE, either as SDO, SS1, or with the full option package Safe Motion. We have an advanced feature upgrade, so we have a speed and torque pre-control. We have a possibility to use a bidirectional torque limitation, and we have extended filter properties. And, as Marvin already showed us, the cogging compensation. The best at the end. For the 2-channel version, we have a significant reduction of the channel price in relation to the L terminals of about 30%.